dipole force. Is another what? Intermolecular force between one molecule and another molecule. Right? So this one forms a dipole. This one is involved in what? Polar covalent compounds. Polar what? And that's what I want to explain. Now, it is a force, it's an intermolecular force that is found, there's an intermolecular force of attraction that bonds polar covalent compounds, forming dipoles. Forming what? Dipoles. Now, they are often asymmetrical. They are what? Asymmetrical. Asymmetrical. What's the meaning of that? I'll explain that to next. So asymmetrical means that the share of electron are unequal. Unequal. That's what is making it to become polar. Now, for example, let's look at this HCl. Are you listening? Are we there?
Yes, sir.
Now, HCl
Yes, sir.
is a polar compound. I will explain why it is polar. I think I need to take my time here. It's a polar what? Compound. Now, the reason why it is polar is simply because the sharing of electrons are asymmetrical. Hydrogen, right, is sharing electrons with chlorine. But chlorine is highly electronegative. Chlorine is electronegative. Don't let me say highly electro. Chlorine is what? Electronegative. What is the meaning of electronegative? Electronegative. Chlorine is electronegative because it always wants to pull electrons towards its own position. Chlorine will be pulling electrons towards its own position. So this electron will fall within the position of chlorine the more. So the density of chlorine will have more electron because chlorine is electronegative. So it's just like a tug of war. So you know, anyone with the highest force will be pulling the rope towards its own position, isn't it? Are you together?
Yes, sir.
That atom with the
Yes,
highest
sir.
electron, with that atom with the highest force, we pull electron towards its own position. So because those electrons are not sharing equally, that chlorine will pull electrons towards its own position. So it will make this chlorine to become partially negative. So because it is pulling electron, it's an electronegative element. So electronegative elements always pull electron towards their own position to have a higher electron cloud density. So whereas the hydrogen will be what? Partially positive. So the hydrogen now will be like partially deficient of the electron because the electron that it is supposed to share, that chlorine is putting it towards its own position. Do you understand what I'm explaining? Please.
Sir, please, can you explain?
Okay. Now we have HCl. Are we together? This HCl,
Yes, sir.
it is covalently bonded because they are both non-metals, isn't it?
Yes, sir.
Now I want to explain why they are polar covalent so that you can understand dipole. They are polar covalent because look at this chlorine. This chlorine is electronegative. Any electronegative atom always pull electrons towards themselves. They are supposed to share the electron equally, right? But the chlorine, because it has more force, it will be pushing the electron towards itself. So because it is pushing the electron, it becomes negatively charged, partially negative. Are you getting it? Why the hydrogen will become partially positive? Because that one hydrogen now is now weak. It is not having the electron in its own possession. The one that is having that electron in its position is what? The chlorine. So that is why we are saying unequal sharing or asymmetrical for polar covalent compounds. You get the logic now? Now, this is not only peculiar to chlorine. We have several other elements that are electronegative. Apart from chlorine, we have other ones like what? Sulfur. Are we together?
Yes,
We
sir.
have oxygen. Are we together? We have
Yes,
fluorine.
sir.
Are we together? We have bromine. We have iodine. Is it clear? All these are
Yes,
mentioned.
sir.
All these are mentioned. Even nitrogen. They are electronegative elements. So whenever they are attached to hydrogen, they are going to make that compound to become polar covalent. Do you get what I'm saying now? For example,
Yes, sir.
H2S is polar covalent. Because of what? This sulfur is electronegative. You get the point? H2O is what? Polar covalent. Because of this oxygen, which is electronegative. HBr is polar covalent. Are you listening, please?
Yes, sir.
Do we understand? HBr is also polar covalent. So once you know those compounds that can form polar covalent, that are electronegative, then you can therefore say they will form what? Polar covalent compound. So you can only find dipole in what? Polar covalent compound, because they are going to give you a dipole. Dipole means what? These two charges, positive and negative, because of the presence of electronegative atom. And this is as a result of unequal sharing of electrons. Does that make sense?
Yes, sir.
Now, if you proceed, you are going to observe something here, which I want you to pay attention to. This one is having 4 different bonds, H, 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 and another H, right? In this case, do you have any electrovalent compound? No. We only have carbon attached to hydrogen, and hydrogen is not an electrovalent compound, an electrovalent atom. Am I communicating?
Yes, sir.
So this implies that this CH4 is what? Non-polar. It cannot be polar. It's not polar. Does that make sense?
Yes, sir.
Good. Now, if I have something like this C, H, 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 and Cl. Now you can see the presence of this Cl here. It will automatically make this compound to become polar because it is electronegative. It will pull electrons towards itself to make this one to become what? Partially negative. You get the point? And this other one becomes partially positive. Do you understand what I mean?
Yes, sir.
So this one, which is CH3, Cl, becomes what? Polar. You understand that?
Yes, sir.
Now, if I now have something like this, Cl, 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 Cl. Now this one is going to be non-polar because this one is pulling like this. It's pulling. This chlorine is pulling. This chlorine is also pulling. They are pulling with the same force. Just that this one they are pulling in the opposite direction. This one is pulling to the right. This one is pulling to the left. This one is pulling up. This one is pulling down. At the end, the net force of the what's it called? electronegative difference will be 0. Because the electronegative difference is 0, this compound, which is CCl4, will become what? Non-polar. Do you understand?
Yes,
Despite
sir.
the fact that it is having chlorine attached, which is an electronegative, because they are all attached in what? Different direction, and they are pulling with opposite forces. The electronegativity difference will be 0, and so they become non-polar because they are sharing with equal electrons with the same force. Does that make sense? Now, if you look at CO2, CO2 is going to be what? Non-polar, because CO2 is like this, double bond O, double bond O. The reason why it is non-polar is simply because this oxygen here, right, is partially negative, and this is also what? Partially negative. This is positive, but they are pulling at what? Opposite direction. This is pulling this way, this is pulling this way. So the net electronegative difference is going to be what? 0. So CO2 is going to be what? Non-polar. Do you understand, please? Oh,
Sir,
now,
please, can you explain, sir? Please, sir.
which part? Which part should I explain? Who is talking, please?
Driver.
Which part do you want me to explain? Is it from now? Look at this. This CH4. You can see that this hydrogen that is attached is not an electronegative atom. I've mentioned the electronegative atom now. I've listed them up there. These are the electronegative atom, isn't it? Common ones are these. Are we together? Chlorine, sulfur, oxygen, fluorine, bromine, iodine, and nitrogen. Is that one clear?
Yes, sir.
Now you are not saying that when those ones are attached to a compound, they can make that compound to become polar because they will make it unequal or unsymmetrical, right? Now you are not saying that for CH4, you are having the atom shared in such a way that the hydrogen are bonded equal. This hydrogen at first is not what? Is not electronegative. You get the point? And they are both shared equally. So because it is not electronegative, we can say this CH4 is what? Non-polar. Is that clear? Is that one understood?
Yes, sir.
Now, but if you
Yes,
now
sir.
replace one of the hydrogen from CH4 with an electronegative atom like chlorine, it can be chlorine, it can be fluorine, it can be any other what? Electronegative atom. If you replace it, it will definitely make it polar because that electronegative atom will pull electrons towards itself to form a dipole. You get the point now? So then it implies that the CH3Cl is what? A polar compound. This one in such a way that all the hydrogen has now been replaced with chlorine, chlorine, chlorine. Now I said in this case, don't be deceived by mere seeing the chlorine saying is an electronegative atom, so it should be polar. No, because they are all having chlorine, and the chlorine are pulling in a what? Opposite direction. This chlorine is pushing to the right, while the other one is pulling to the left. So their network force is going to be 0. Up, down, right, left. They are pulling with the same force. So because they are pulling with the same force, they are sharing equally. And so the network force is going to be 0. And as a result, the electronegativity difference will be 0. And that will be what? Polar. Because it's not going to form any dipole. They are sharing equally. You get that?
Yes, sir.
So wait back. You are the one that said
Yes, sir.
and we are explaining. Do you understand?
Yes, sir.
Now, the same thing is applied to CO2. If you look at CO2, you realize that CO2 is C double bond O, C double bond O. This oxygen is part of the electrovalent atom. But because oxygen is pulling, one is pulling to the left, the other is pulling to the right. So the network force is going to be 0. And as a result, the dipole moment is going to be what? 0. And so the electronegativity difference is 0 and it becomes what? Non-polar. Does that make sense?
Yes, sir.
Do you get it,
sir.
everybody?
Yes, sir.
Why is it going to be polar? If you look at it, you have C, Cl here, Cl here, Cl here, and H here. Are we together? If they are sharing here, if this is pulling this way, this is pulling this way. You get that? These two are equal now. But it's not equal with this. This one, are you listening? This is
Okay.
negative and this is what? Positive. So this will make it what? Polar. Does that make sense, please?
Yes, sir.
So now, if you are now having HCl bonding with another HCl, are we together? Bonding with another HCl, bonding with another HCl. Are you there? Now this is a molecule of HCl with another molecule of HCl with another molecule of HCl with another molecule of HCl. Are we together? Now this
Yes,
first
sir.
one is partially negative. Do you agree? Because this is partially positive. Dipole. Does that make sense? Because this chlorine here is electronegative, so it is pulling electron towards itself, so it is partially negative, right? Am I communicating?
Yes,
sir.
sir.
Now the same thing to this. This one is also partially positive, partially negative, partially positive, partially negative, partially positive, partially negative. Now, the force that binds molecule 1 and molecule 2 together. Look at it. Hydrogen is bonded with what? Chlorine, right?
Yes, sir.
Now, you can see that it is forming a dipole because this is a polar covalent compound. Polar what? Covalent. So, the type of bonding that binds polar covalent compounds together, you can see that now. An example is HCl. So, that bonding that binds HCl with another HCl, which is a polar covalent compound, is what? Dipole. A dipole force. Dipole force. You get the point?
Yes, sir.
Good. Now, note, this dipole force is also here. Dipole force. Are we following, please?
Yes, sir.
So, this is going to be applicable to all other ones. Like you have, for example, if I have something like H2S bonding with another what? H2S. Bonding with another what? H2S. You get the point? So the bonding here will be what? Dipole force. Does that make sense, please?
Yes, sir.
Because this one is partially negative,
Partially positive.
partially positive, partially negative, partially positive. So the type of bonding that binds what? Polar covalent compounds together is what? Dipole force. Is that a dipole force? Now, there is just an exception. That exception is where I'm going to talk about what? Hydrogen bonding. Am I communicating?
Yes, sir.
Now, when these three